Good morning, ma'am. My name is Ashlyn from Physical Science Department, Section A. I am going to take what is measurement. So, introduction. Measurement is the basis of all important scientific study. It plays an important role in our day-to-day life. While finding your height, buying milk for your family, etc. So, measurement questions like how long, how heavy, and how fast. It is defined as a determination of the size of magnitude of the quantity. So, a physical quantity and its units we are going to see. It is a quantity that can be measured. A physical quantity can be classified into two, the fundamental and physical. The quantity which cannot be expressed in terms of the physical quantities is called fundamental quantity. Example, length, mass, time, etc. And then the quantity which can be expressed in terms of physical quantities is called physical quantity. Example, area, volume, density. So it is a numerical value. So the unit is a standard quantity which is the known quantity or compared. It is defined as a specific magnitude of physical quantity that has been adapted by law or convention. For example, feet is a unit for measuring length. That means 10 feet is equal to 10 times the definite predetermined length called feet. Earlier different unit systems was used to people from different countries. So the unit systems of the earlier time, it's at the end of the World War, there was a necessity to use worldwide systems of measuring. Hence, SI, the full form of the SI is International System of Unit. System of unit were developed and recommended by General Conference on Weight and Measures at Paris in 1960 for international usage. The SI system of the unit is moderate and improved form of the previous system of unit. It is accepted in almost all the country. It is based a certain set of fundamental units from while derived unit are obtained by proper combination. There are 7 fundamental unity in the SI system of units. So I am also shown what are all the SI system of unit, the 7 fundamental unit, which means first one is length. The SI unit is meter, the symbol is M, and then mass, kilogram, kg, time, second, S, and temperature is Kelvin, K, and amount of substance is mole, symbol is MOL, and electric current is ampere, A, and then the luminous intensities is candela, is CD. So, and also I'll show the fundamental units, the derived SI unit. Examples is volume, it's cubic meter m cube, density kilogram per cubic meter is kg per meter cube, speed meter per second is m per second, Newton kg m per square is n, and energy is joule, J, pressure is pascal, the symbol is Pa. So the length, we are going to move to what is length. Length is the extent of something between 2 points. The SI unit of the length in meter is the distance traveled by light through vacuum, the given seconds. So in order to move very large distance, we use the following unit, which that are astronomical unit, light year and parsec. So we are going to learn what is an astronomical unit. It is the mean distance of a center of the sun from the center of the earth, which means simply the distance between the sun and the earth. So AU, 1 AU. The AU is a short form of an astronomical unit, is equal to 1.496 into 10 power 11 meter. So the light year. Light year is the distance traveled by light in 1 year in vacuum, and it is equal to 9.46 into 10 meter. So parsec. Parsec is a unit of a distance used to measure the astronomical objects outside the solar system. 1 parsec is equal to 3.26 26 light year. To measure the small distance, such as distance between two atom and molecule, size of the nuclear and wavelength, etc. So mass, it is a quantity of matter contained in a body. The SI unit of the mass is kg, already we study. 1 kilogram is the mass of particular international prototype cylinder made of platinum iridium alloy, kept at the International Bureau of Weight and Measured as service vans. Yeah, it's true. In nowadays also, it kept in a International Bureau in France. So note that. So the unit unit of a gram is g, and the milligram is mg, and the sub multiples of tens is 1 by 10th of the unit kg. So there is a 3 point and how 1 gram is converted into kilogram, and 1 mg is converted into kilogram, and then 1 quintal is converted into 100 kilograms is shown how. So the atomic mass unit. The mass of proton, neutron, electron can be determined using atomic mass unit AMU. AMU is a short form of atomic mass unit. 1 AMU is equal to 1 by 2th of the mass of C12 atom. So time is a measure of duration of events and intervals between them. The SI unit of a time is second. 1 second is the time required for the light propagate the given meter through vacuum. It is also defined as 1 per 86 400th part of the mean solar day. So, what is temperature? It is a measure of hotness and coolness of our body. The SI unit of the temperature is Kelvin. 1 Kelvin is fraction of the thermodynamic temperature of a triple point of a water is commonly known as an absolute zero. The other unit of measuring temperature in the degree is Celsius and Fahrenheit. So, degree and Fahrenheit is also a unit to measure temperature. So they're very important is rules and conversions of lighting as a unit. The unit named after scientists are not written in a capital letter, which means the unit, the starting, for example, Newton. There is a Newton. The N should not be in a capital letter. It should be in a small letter. Example, Newton, Henry, Ampere. The system of the unit name after scientific should be written in an initial capital letter. For example, the symbols should be in a capital letter, which mean example N for Newton, H for Henry. The small letters are used as symbols for unit, not derived from the proper noun. Example M for meter. Non-full stop or rather punctuation mark should be used within at the end of the sentence. There is no more full stop and no more commas, etc. Example 50 meter, not as 50 meter full stop. No. So the symbol of the units are not expressed in plural form. Example 10 kg, not as 10 kgs. So when the temperature is expressed in Kelvin, the degree sign is omitted. Example 238 Kelvin and not as 238 degree Kelvin. So uses of Solidus bar is recommended for indicating divisions of one unit symbols by another unit symbol. Not more than one solids is used. Example meter. Mm is -1, not as m per second. The number of the units should be separated by a space. Example 15 kg ms power -1, not as 15 kg ms -1. So, accept symbols alone should be done. Example, ampere should not be written as AMP. So, the numerical value of the physical quantity should be written in a scientific. For example, the density of mercury should be written in 1.36 to 10 power 10. For kgm -3, not as 13,600 kilometer per kilometer -3. So, I have also attached a video what is in units and physical quantity. So these are all tells about what is time, what is length, and what is mass, and etc. So thank you.